My second example on my PowerPoint is this function, tan to the negative 1, tan 2 pi over 3. And I want to evaluate that. I'm looking to see if this number right here, 2 pi over 3, is in the domain of tan. So is 2 pi over 3 in the domain of y equal tan x? So I look on my worksheet that I sent to you guys, and I'll try to find what the domain of tan is. And the domain is from negative pi over 2 to pi over 2. So I want to know if 2 pi over 3 is in between there. So 2 pi over 3 is not between these two numbers, between negative pi over 2 and pi over 2. Since that's the case, this is a harder problem. Okay, now for my next example, I want to show you, I guess I'll call this example 3, but this is on your PowerPoint. I want to show you this problem, the inverse sine of the cosine of pi over 6. So what you're seeing now in these examples is that the functions are not inverses of one another, they're different. In these situations, you can either use a right triangle or the unit circle. This is a problem in which you want to use the unit circle simply because you have pi over 6 on the unit circle. So we're going to do the inside part first. So we're going to evaluate cosine pi over 6. So I go to pi over 6 on my unit circle, and I see that the cosine value is the square root of 3 over 2. And then what I'm going to do is do the outer part of that. I'm going to do the inverse sine of the square root of 3 over 2. And using your calculator, you see that that gives you 60 degrees or pi over 3. So that's a unit circle question, and it's fairly easy to do. So I want to do one last one here, you guys. So my last one I want to do is one that's not on the unit circle. So I'm going to do cosine inverse tan, and it is square root of 3 over 4. Okay, now this value is not on the unit circle. I don't want to use my calculator because I'm interested in getting exact values. So what we want to do when something's not on the unit circle is do a right triangle. And since this is a positive value, I'm going to draw my right triangle in the first quadrant. And since tangent is y over x, my numbers go here. If I do the Pythagorean theorem here, I have 4 squared plus the square root of 3 squared, giving me my hypotenuse squared. So that's 16 plus 3, which is 19. So that r squared is 19, and that means that r is the square root of 19. So my hypotenuse is that. So we fill in the right triangle like we always have. And this is my angle. This is my theta, which is really what this whole thing is. This is theta. So that just allows me, I'm only using that to set up this triangle. So what I really need to do, my problem that remains is that I have to find the cosine of this angle. And according to what we've learned, the cosine is the adjacent side, or the x over the hypotenuse. So that will be 4 over the square root of 19. So that's how to do a problem if this value here is not on your unit circle.